Students, let's continue doing the quick review of factoring. The only thing that I would like to cover, to finish covering, will be perfect square trinomials, difference of squares, and perfect cubes. Hopefully this video will be shorter than the previous one. So let's start with the perfect square trinomial. The important thing is to recognize the pattern. A squared plus 2ab plus b squared, and a squared minus 2ab plus b squared. Oops. If it's plus, this will be plus, minus, minus here. Important, folks, always b squared is positive. If you see a b squared, a negative, this is not a perfect trinomial. How do I recognize the pattern? Let's go ahead and explore this one. Ax squared plus 12x plus 4. We need to ask ourselves, if this is a perfect square? Yes, because this will be 3x squared. 3x times 3x, that will be 9x squared. What about the 4? Absolutely, this is 2 squared. 2 times 2, 4. Okay, so we already recognize the quote unquote the A and the B. Now we need to verify the middle term. The middle term should be plus twice AB. This is A, this is B. If I multiply 3 times 2, that will be 6x. Twice that will be 12x, which is exactly what we have in the middle. Therefore, this one passes the pattern of perfect square trinomial. Therefore, this one factors as 3x plus 2 squared. And we are done. Notice that if this guy was minus 12x, this guy will be 3x minus 2, and the rule still applies. Let's try another one. What about if we try 9y squared plus 24y plus 16? Okay, let's see. 3y times 3y, I mean 3y is 9y squared, of course. 4 times 4, that would be 16. Now, is this equal to that? We don't know. We'll see. 3 times 2, that would be 12y. Twice 12 would be 24. Perfect. So this one will factor as 3y plus 4 squared. Let's try another example. What about the following? Let's try the following example. 64m squared, blah, 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 plus 1. Let's say that this is minus here. What term I need here in order to be a perfect square? I don't know. Let's think about it. 64m squared, of course, its square root will be 8m, right? So 8m times 8m will be 64m squared. The 1, of course, is the square root of 1 is 1. So we need here what? 8m. This is minus 1 squared. What term do I need here in the middle? It will be 8 times 1, 8. Twice that, double of 8 will be 16m. You know, if I have any other number, if I have a number other than 16, it will not be a perfect square. But with 16, we guarantee that indeed passes the pattern. 8 times 1, 8. 8 times negative 1, negative 8. Twice that will be negative 16m, and we are done. Let's talk about now the difference of squares. A squared minus b squared always factors as a plus b times a minus b. As I mentioned before, a very important word we need to recognize. This is a multiplication of conjugates. We use conjugates a lot, especially when we're dealing with a square root with radicals. So conjugates, multiplication of conjugates, difference of squares. A square minus b squared. So we just do a couple of examples. These are very easy to recognize. What about if I have 121x squared minus 144y squared? By the way, all the examples I'm doing, I'm assuming that there is no greatest common factor we should factor out first. So of course, we know that 11 times 11 is 121, 12 times 12 is 144, and this is minus. Therefore, this one will factor as what? 11x plus 12y times 11x minus 12y. And weird one. This is 11x there. What about 25x squared minus 1? 25, 5 times 5, 1, 1 times 1, therefore difference of square, 5x plus 1 times 5x minus 1. I'm being sloppy right in here. What about if I have 36p squared minus 49q squared? Okay. In this case, I'm going to do 6 times 6 is 36. 7 times 7 is 49. So this one will factor as what? 6p. I'm going to put the minus this time first. 7q times 6p plus 7q. Doesn't matter which one is plus and which one is minus. Commutative property of multiplication. Last but not least, let's go ahead and attempt the perfect cubes, very unique. Once it's obviously the sum or difference of cubes, a cube plus b cube is a plus b times a squared minus ab plus b squared. A cube minus b cube is a minus b times a squared plus ab plus b squared. Something that I should mention, this trinomial here is prime, this guy here. Therefore, they don't factor anymore. This is it. That's its simplest form. These guys are prime. This guy and this guy. Anyway, so let's go ahead and try two examples of this. They're not that difficult to recognize. U cubed minus 125. Of course, as long as we recognize that u cube is the same thing as what? U, with this kind of silly, u cubed minus, and 125 is the same thing as 5 cubed. So now we recognize this is a difference of cubes using the formula. A will be u, b will be 5. Therefore, and this is minus, so we will follow this pattern. U minus 5, that's my AB, times. We square the first one, a square, that will be u squared. For the middle one, we multiply 5 times u, 5u. And for the third term, we square b. So 5 squared, that will be 25. So this is minus, plus, plus, done. Let's try another one. What about 64? What about 64 plus 27x cubed? Okay, let's use the same trick as before. 4 times 4 times 4 is 64, so we already recognize A in our pattern. 27x cubed is 3x times 3x times 3x, so 3x cubed. So now we have our A, this is plus, so we follow the first pattern. A will be 4, and B will be 3x. Okay, so that's it. A is 4 plus 3x. Perfect. So that's the toughest part. Now we follow the pattern. It says, take A squared, 4 times 4, 16. For the middle term, multiply the two of them, 4 times 3x, that will be 12x. And for the third term, square B, 3x times 3x, 3 times 3, that will be 9x squared. So this is plus, minus, plus, dot. And that will do it. Let me try one more. I was going to stop there. However, I realized I didn't give an example factoring greatest common factor first. I always assumed that it was in its simplest form, but I think I should do it now. So I have 500p cubed plus 4q cubed. Anyways, notice folks that 500 is the same thing as 4 times 125. 4 is the same thing as 4 times 1. So we can factor out F4, and I have 125 p cubed plus 1 q cubed. So therefore, let me just put here. 125 is the same thing as 5p cubed. And of course, Q will be, well, of course, Q. So I have my A, I have my B. So the A will be 5P, and the B will be Q. And we use the first pattern. So this equals to, let me start here. This will be 4 times what? A plus B, so it will be 5P plus 1Q. How do I get the first term here? We square the first one, 5p times 5p, 25p squared. How do I find the middle term? We multiply this to 5p times q, 5p q. And the third term, we square the b, in this case q times q, of course, q squared. And see, this is plus, minus, plus, dot.